So let's go over a couple more complete the square examples. I'll go off the classwork that was assigned, the written exercises. So this is page 415. Let's try number 1. Okay, the equation looks like y squared plus 4y plus 3 equals 0. And right now, you already know one way of solving this, that is with factoring. You see that, okay, my factors of 3 are 3 and 1. Together they add up to this thing, 4. So it looks like plus 3 and plus 1 equals 0. By 0 product property, y plus 3 equals 0, so y has to equal negative 3. Y plus 1 must equal 0, so y equals negative 1. Okay, that's the factoring method. Right, so here's complete the square. It's another way to go about solving these equations, not with factoring. Here's completing the square. And we're using this to solve for y. So you can imagine, if we go back to like the algebra tile idea, here's a big y tile. Okay. And then you want to make a square, so the length and width have to be the same. Here's y and y, you split it in half, y and y. And then you notice the stuff that's here, right? You have 1, you have 2, you have 3, and oops, you're a little bit short. You need one more block that goes in this slot, right? Missing. Okay, so far so good with this picture. And you'll see why the name is completing the square, right? Because now, at this point, because we're missing one tile from getting a perfect square, we're going to add it in to both sides. So originally, this thing is y squared plus 4y plus 3, okay, equals 0. When we add 1 to both sides, it now becomes plus 3 plus 1 equals 0 plus 1. So far so good? And now, at this step, we have y squared plus 4y plus 4 equals 1. Without leaving the 1 on the right-hand side over here, we're going to factor this stuff. It becomes y squared, y plus 2 equals 1. And we can rewrite that. Y plus 2 squared equals 1. What's up? What'd you notice? Okay, I'll give you a little bit of time. Okay, what is it? Yes. Yep. Yep, except we always want it to be like this though. It's always something squared. Yeah, like here, yes. And the length and the width are the same always, right? Because like in this picture over here, we drew a rectangle. It looks like y plus 3, y plus 1, right? So that looks like 1, and then 1, 2, 3. Mm-hmm. All right, so far so good. Is it making a little bit more sense? I hope the picture helps. So from here, now we can solve for y. We have to undo the squaring that's present. The opposite of squaring is square root. So we're going to take the square root of both sides, like that. So then that becomes like so. We undo squaring, so we're left with just the inside stuff, y plus 2. And this part, we have -1 and we also have +1. Okay, that's going to be like one of the another steps. There's two potential answers here. Because you're squaring and then square root, this y over here could be positive or it could be negative. And that's what we're trying to represent over here. And then we subtract 2, y equals plus or -1 minus 2. And you'll see from my work from last week that this is where it leads you to those two answers. +1 minus 2, -1 minus 2. +1 minus 2 is -1. -1 minus 2 is -3. Those look familiar? Hey, it's exactly as we got up there. When we put them side by side, when things are factorable and you can see that, yes, it's much faster to factor, but I'll pick a problem next where we can't factor it, right? The left-hand side and using the zero product property, this way over here, it's not always going to work. Completing a square, although it's longer, will always work. And in today's review, I went over this thing right here. So that's actually vertex form. This is vertex form. So the equation for vertex form that I didn't emphasize that much looks like this. +1 or plus k, or y minus k equals a times, like that. So for this equation, for this quadratic, the vertex is at -2, -1. In green. So that's kind of the new stuff. When we talk about more word problems, you'll have to often find the vertex, and this is what it's talking about. And we'll practice vertex form a little bit more in the coming chapter. But so far, it's this stuff on the right that we're reviewing, completing the square. Shall we do another example? Take that as a yes. So here's, let's say, number 11. Well, actually, number 9 looks good. Number 9 from page 415. Okay, that looks like y squared minus 8y equals 4. Okay, thanks for letting me know. So this is going to be recorded, and in case students that aren't able to join us, they can refer to it when everything's up and running again. Be sure to tell him to tell his other teachers in case he can't make it. Tell him why so they don't mark him absent. He's here. Please pass that on for me. Thank you. Here's number 9, where we see that factoring won't help us. Okay, we can try factoring. Oh, one more. Okay, so we can try factoring. So far, we are reviewing. Well, okay. So right now I'm sharing my screen. I'm reviewing some of the classwork from last Thursday. This is number 9 on page 415. When we try to factor this and do some subtraction, looks like so. Notice here, none of the factors of 4 can make -8. Doesn't work. Tasha, I'm gonna temporarily mute you, and if you have questions, you can type it out. Or yeah, makes sense. Thanks. Okay, so that doesn't work, which is why we have this complicated completing the square method. That way always works. So in this picture, we have a y tile. If we want to start with the visual representation, there's y squared. We're going to break up that 8y in half. So it looks like 1, 2, 3, 4. 1, 2, 3, 4, like that. So those are all y's, and we notice over here that there should be a total of 4 by 4, or 16 ones. Okay? And right now, y squared, so looks like this, minus 4 equals 0. Right now, we only have 4 of them. We need 12 more to complete the square. Okay? Visually, that's what we're going to do with the symbols coming up next. So, y squared plus 8y, if we already have -4 of them, we need to add on another 12. Okay, like that. Sorry, I'm like thinking. Sorry, it's not another 12. Okay, so this example is a little bit more complicated because there's positives and negatives going. Let me see if I can. So my picture actually, it's like I have to make 16, positive 16 tiles here. So really, I'm adding, if I'm already at -4, I have to add positive 20 things. Correct? That's confusing. Why don't I write it this way? All right. From here, right? Without moving it. This was for the purposes of the picture. From here, we add on 16 and 16. That's from this part. Y minus 4 squared equals 20. Right? Getting here is the first step. Any questions? All right, question. Where did the 16 come from? The 20. The 20 came from this side. See, we added 16 to both because that's what we needed to complete the square. So we need to make 16 to complete the square. All right. So from here, there's going to be some undoing. The first step is undoing the squaring. We know that square root undoes squaring. So it looks like this. Y minus 4 equals. So here, the plus or minus, right, positive square root 20 or negative square root 20 comes from this side, right? When you square something, regardless of whether, like, whatever you're squaring, positive or negative, the end result's going to be positive, correct? So we could have started with like negative 20 squared, which is 400, and then taken the square root, and we get 20 at the end. That's the same as if we squared 20 to get 400 and taken the square root. To kind of account for these two sign differences, right? Positive here, and then this one's going to be negative and positive. That's why we add in these symbols. It also reminds us that there are two answers. From here, y equals positive, negative, actually. So we add 4 to both sides, and we have this thing. And you'll see often, like in the back of your textbook, when we write things with square roots in them, we're going to put the numbers first, and then plus or minus square root of 20, like that. Okay, so that's our answer for number 9 from page 415. The back of the book also simplifies this more. We didn't talk about this much, like at all, but square root of 20, you can break that down into square root of like 4 times the square root of 5. You know what the square root of 4 is. That's 2. So then when you separate them out like this, and then put them back together, that's where they get 2 root 5 from. So root 20 equals 2 root 5. This is what it means by simplest radical form. Right now, that's just extra. If you can get here, that's all I'm looking for. This is complicated. All right, what's up? Question. Okay, which step? Here, like this one? Okay, so you're asking right now going from here to here. Why? Because if you're trying to undo this squaring right here, if you only took the square root of one side, then you would change your whole equation. It's like why we like add 4 to both sides to undo this subtraction right here of 4, or adding or dividing. We must do this square rooting on both sides. It's an operation, just like adding and subtracting. You could, if it was simpler, like here, right, you can kind of guess what it could be. But in this case, it's much harder. Like, we could never guess 4 plus or minus square root of 20. That's hard. From here? Yeah, because it was being subtracted. We're trying to get y by itself to solve. Oh, so Yes, two different ways to write it. The reason here being that if you write it this way, it looks a lot like this. See the difference, right? Because of this, and it's a really easy mistake to make, right? Like when you're writing something, suddenly your pen goes like that, when you really meant this. If you put your numbers first, then your square roots, that's never going to happen. And that's why it's recommended that you write it this way, so that you avoid this mistake. Yes, this here, plus, wait, where? Oh, here, this one, right? Down here? Okay, so this one is actually saying uh, plus or minus square root 20. So, my, okay, give me a second. My thingy is not behaving, so, alright. It won't let me scroll. Okay, so this thing is actually saying 4 plus square root 20 and 4 minus square root 20. Yes, it could be either. It could be positive or negative, or you can think about it like plus or minus. Cool. Yes, we're going to get lots of practice on Thursday when we go to the quadratic formula. So this is going to happen for another lesson. All right, so far so good. That's number 9 from the classwork.